Welcome back. Today we're revisiting these 2 meters that I showed in a previous video and mentioned that there was a lot of corrosion on there from the batteries that we had to clean off. I also mentioned that I needed to do a little research to figure which type of solution we were going to use to clean this up. And I mentioned that because different batteries have different kind of chemical compositions, as you can imagine. And an alkaline battery is exactly what it sounds like. It's alkaline, it's not acidic. Whereas a lead acid battery, as you can of course assume by the name, is an acidic battery. So when you clean corrosion from an alkaline battery, you're going to want to use an acidic source such as vinegar. The other thing is, if it's acidic like a lead acid battery, you're going to want to use something that's basic or alkaline like baking soda. So it definitely depends on which thing you're cleaning, depends on what kind of solution you need. Now, I mention this because these particular devices were back from the era of time where carbon zinc batteries were a lot more popular. And one of the devices actually mentions to use carbon zinc batteries. Now this one here says use alkaline batteries only, and we can see there's some green corrosion big time in there. Then the other one here, I believe, says to use carbon zinc somewhere on here. And this one's got a little bit, different kind of corrosion on here. Not as bad, but there is still some on here. Now we did try to clean this in the other video with, I think, alcohol, or I don't really remember what I used. But I did mention that inside here there is some corrosion on the back sides of the terminals, and we might have to take this apart. Now, unfortunately, I did try taking this apart in the last video, and we couldn't get too far into it because it seems like it snaps together, and I didn't want to break it. But we're going to go down that rabbit hole in this video. The other one here is very bad. I tried scraping this off, it didn't scrape off, so this may be just beyond repair. The problem with some of the corrosion is it actually corrodes to the point where it starts to eat the metal that's made out of the terminal. And a lot of the sources I saw said that the reason why this is green is because of the actual copper content. And we might have to actually restore these back to their original new condition, besides just getting the corrosion off. Now, I'm assuming for this particular one here, for the alkaline, we're going to use the vinegar solution. The other one, I don't know if this had the alkaline batteries in it or not, and the corrosion isn't as bad. So we can try both methods. It's not going to hurt if you use the wrong one, it just won't work. To use the baking soda, we're just going to use a little bit of water and make like a paste, and I'll probably just use an old toothbrush and maybe like a little, this is a top to a spray can or something, maybe we'll just like dip that in it and spray it on, brush it on. Or the vinegar, we can just use a little Q-tip or some kind of cotton swab and just swab that on. Of course, you're going to want to make sure you wear gloves. When you're working with chemicals like this, they are corrosive, so putting gloves on is definitely a good idea. Also, sew a safety glasses just in case you get splashed in the face, so we will have proper protection on. And also, you don't want to make sure you don't get any of the stuff on your clothes. That's definitely a bad idea, because this will stain, especially if this starts to come up. It's been a while since I had last touched these, and since I had the last video up on these. And the reason is because I just wanted to research this, make sure we're going the right route. There was a lot of information out there. A lot of it was very consistent about using this method. So that's what we're going to go ahead and give a shot. So I'm going to go ahead and put all the safety gear on, and I guess we'll start with the vinegar on this particular unit here. Let's have a nice close-up of that corrosion, just so you can see the severity of it. This is why you don't store devices with batteries in them, especially long-term. I have read stories, though, doing the research on this, that people said that they've had certain brands of batteries last a very long time, especially in that kind of a situation where it's just been in storage. So I'm actually surprised to hear those stories. I don't know what brands were in here. The batteries were already removed once I've got this in my possession. But you can see, maybe on camera, that the corrosion's so bad it started to eat away at the metal inside of those terminals there. So this may be all for naught, but nevertheless, I am going to still try to take this apart and open it. I did get this particular one opened already, and I did the teardown in the other video on it. Pretty bodgy device here, but it doesn't work. There's very little to no connectivity in the batteries, and this thing just doesn't power up. So we definitely have to clean the corrosion. The other one I mentioned, I didn't have batteries for. Well, I got the batteries now. I just haven't tried them out yet because I do want to get these a little cleaner. Some of these terminals, like you can see, are nice and bright, shiny like that, but the rest of these here are not. And those are the ones that are clean. The ones that are obviously duller are the ones that need to get cleaned up. So we'll definitely give that a look. But I'm going to go ahead and pour some vinegar into my little cup here. This was just the smallest thing I could find in the shed here. I don't like wasting, you know, paper cups or anything like that. Just a little will do you. Any brand of vinegar. This is just what I happen to have in the closet. The baking soda, which is a no brand baking soda, by the way, I picked up at the dollar store for 59 cents. If I needed vinegar, I would have grabbed it there too, but I had it already. But anything like that will do. So I'm just going to go ahead and soak this in and just get in here and clean these terminals up and see if it actually oh, actually it looks like it is doing something. Yeah, it's doing something. It's changing color a little bit. It's kind of softening up. You could see it on the end of the swab. And the other thing too is, I should have mentioned earlier, you want to do this in a well ventilated area. I am in my shed, but I have both doors wide open. As you can probably hear the people in the neighborhood sawing and the wind blowing and whatnot. But and there's also a little vent in here, my solder extractor system that I have. But you definitely want to do this in a well vented area because, well, first of all, you know, vinegar has its own smell. But, you know, like I said, there's chemical reaction going on here. Now that really didn't clean it up too much, so I'm going to go ahead and keep applying this. In some areas where it wasn't as heavy, it's doing a better job at. But it definitely is cleaning up in here. But ultimately, I think I'm going to have to hit this with a wire wheel or something. I do have a steel wire wheel, but it was recommended to use a brass wheel, so I might have to take a run over to the Lowe's store over here, which is my closest hardware store, and just pick up a set of brass wheels, because ultimately I think that's what's going to have to happen. But it's definitely looking a little better. Perhaps I could try the toothbrush. I do have that set up right here, and we can give that a quick scrub and see if that helps. I'm not too worried about making a mess. I am in the shed here. I want to make sure, though, I don't get too much, you know, liquid going down into the machine board here, so I don't get it wet. That's only marginally better. Ultimately, this is definitely going to have to get hit with the wire wheel. There's no doubt about it. See, I don't have anything here in front of me to use. I do, like I said, I have the steel wheel, but that's going to affect this too much. Perhaps just dipping some of that on here and just letting it soak on there is another good idea too. Let it sit like that. The other one here, while I have it in my hand and in front of me, we can go ahead and try that. Since I have the toothbrush, I'll just try to scrub that up. It is interesting how much, you know, stuff actually corroded back here behind this panel. It's corrosion. It's like an electrolysis kind of reaction, you know, using different types of metal, and something leaks out, and chemical reaction. It's a whole thing, but it could affect a lot more than you think it does, especially over time. The other thing I don't have out here with me now, I have to run back in the house and get, is isopropyl alcohol. You're going to want to clean up everything in here with the isopropyl alcohol to get the, you know, vinegar remnants off of everything. This is, you know, looking better to the naked eye. I don't know how it translates on the camera, but those terminals are looking better. I can try the baking soda solution in this one just to make sure it's, you know, the vinegar's not doing its thing. They said you should hear some kind of a fizzing noise. And I do, actually. I do hear a little bit of a fizzing noise. It's kind of hard to hear over all the noise outside, but I definitely do hear something. I wonder if I hear that in the other one here. No, I don't really hear anything on that one. Yeah, this is going to have to get scraped off ultimately. It's definitely not looking good right now. I can't even really get the brush behind this, and unfortunately, as you can see, they're riveted into the plastic case here, so I can't even really get them out to work on them outside of the unit here. So that's kind of a drag. Well, I think like I said, I'm gonna have to wire wheel these off. I should go take a run right now and go get the brass wheel for this. That would definitely make this an easier job, I'm hoping. I mean, there is a possibility, and I mentioned this earlier in the other video, that this could be so corroded it's just done. You know, once you start grinding this, it could just break. I mean, it's still got some spring to it, so hopefully that's not the case. Before I do that, I'm gonna go in the house too. I'm gonna grab the alcohol, and I'm just gonna clean these pads up with that. And I'll grab the AAA batteries, and we can see if maybe this one works. It ended up being a quick 20-minute trip here and back, and just picked up a couple of these steel wheels. So we'll give that a shot. Actually, I have the Dremel hanging from the ceiling up here. I'm gonna get my extension so I can just do it a little bit easier. Alright, we're all set now. Let's see if this is going to give us the result we want. I'm going to go ahead and turn it on. It's kind of boring watching me do this. I just did a little test shot though, and it seemed like it started working. Oh, also, of course, need the studio lights. So yeah, I'm going to go ahead and give this a shot and see what happens. Here's what it looks like after a few minutes. You can see I got a good amount of the corrosion off. There's some spots I just can't get at. I got the wheel as best as I could in there. Like I said, I'm on a shaft here, so I got the thin mount here, so I can actually get a fingertip control in here, which was good. But I still really can't get into that spot. I can hit it, and it is removing stuff, but it's just not removing it at the rate I'd like to see it remove it at. I'm gonna go ahead and hit this again though, because I want to get a little bit more of this off where the center contact is. You can see these two contacts here were pretty clean, but they do look a lot nicer now. I'll flip it over, show you the other side here. Yeah, not too bad, not perfect, not too bad though. This is a start. Actually, I hit it with some more vinegar just to see if I could try to dissolve maybe the undercoat. And also, I didn't mention, I have some deoxit, which is always good stuff to try to use. So I'm going to try putting some deoxit in here and see if that will help as well. But I'm going to go ahead and keep chipping away at this. You can see, if you haven't used these conical or even the wire wheel type discs with Dremel tools, or pretty much I think any tool will do it, but if you'll notice they're straight when you start, and then when you're done they kind of have the they go in the direction of the rotation, so it feels like after a while you tend to lose the leading edge of this. So I have another brush inside that I can use. You want to be careful though, by the way, I should mention, because these do come out and you can see there are some loose threads from this wheel in here. So when I'm done with this, I'll probably take the air compressor and fire it up and just blow out anything inside of it, just to make sure there's no little bits. And of course you want to inspect just to make sure, because you don't want to short anything out, especially if it's in one of these meters like this, because that could cause a big issue. But we'll definitely have to pay attention to that. And this is also already pulled apart, so I can give it a good visual check once I'm done with it. But yeah, I'm going to go ahead and just keep hitting at this just to give it more of a fighting chance to get this stuff off. Well, I think this is about as good as I'm going to get it. There really isn't any more I can get off that I can do. As you can see around, the plastic got pretty beat up from the brush, but that was expected. You know, I can't get these things out, so that's as close as I can get. So I went ahead and got some batteries. We're going to throw them in there and see if I can get this to go. Unfortunately, the label's a little bit chewed up, but I do know which direction one battery goes, so they should all fall in series connection, as we can tell by the terminals. There's the positive terminal here, and this is the negative terminal, and the rest of these are just connected to each other. So I'm going to go ahead and pop these batteries in. Now, this is kind of a hokey battery compartment, and these terminals are a little beat up, so it's kind of hard to get these in here. But we're going to go ahead and snap them right in, just like this, using care not to get the tips of my fingers stuck in the terminals. And hopefully we get something. Nothing. I push the buttons, I get nothing. There's a wire here. with juice running through. If I clamp this around here, it doesn't even light up for anything. Alright, womp womp. We'll have to bring this inside and put it on the bench and see if I can test to see if these batteries are making, you know, connectivity between them all. That'll tell us if the terminals here are bad, and if not, then we'll have to dig further and see if the power is getting to the next spot on the board. So we'll put that on the side over here to take a look at. Oh well, I should mention I ran inside and I grabbed my brush set too. There's a stainless or a steel brush in here, and there's also a sprash brush. So I used the two of those to, you know, clean the terminals and to find spots where I couldn't get. So that brings us on to the other guy here. Again, terminals are as clean as I'm going to get them. They're not bright and shiny like the other two here are, but you know, they should work. So let's give this a shot. This one luckily has, you know, the positive and minus symbol at each terminal here, so it doesn't make that easy to hook up. These are, by the way, both are brand new batteries. Let's see what happens with this one. There's a button on the side over here. Oop, see, when I push it, the needle moves, so that's a good sign. So I guess we're going to have to go ahead and test this one out since it is working so far. I'm just going to go ahead and slap the battery cover on the back here. I should mention that I do have these both disassembled, so they're kind of just snapped together, so I have to be careful. But I'm going to put this down to the lower range up here to 125 volts, and let's see if I put this around one of my wires here. I think you actually have to have a unshielded wire. These are actually, you have all three cables here together. I think you need a single wire. Either that or I'm not drawing enough juice to trigger this thing. So once again, I'm going to have to bring this in where I can actually test it in a better environment. But so far, we got movement on the needle, so it's definitely getting juice to the device. The other guy here, not so much. So I'll get everything wrapped up out here and take this inside and see what we can get. All right, now that we're back inside, we can go ahead and test this meter out, find out what's going on with it. I guess one of the things we can do first is check the voltage of the battery. Now, I don't have an official battery tester, which does put a little bit of a load on there and tells you how much life is left. But we do have the multimeter, and I can see if I can put this on DC volts and check this and see if we have 1.5. And there's 1.6, so that's definitely a good battery. We're going to do this to the other ones here. Yeah, 1.6. Now they came out of the package new, but like I said, this wasn't working. We wanted to check this out, make sure it is indeed not the batteries, which you can see all those are above 1.5 volts, so we know those are good. Then we can put this over to continuity mode, so now when the leads touch, we get a beep. And what we could do is we can probe in here the terminals to see if they have continuity within each other. So right away we can see there's nothing here, there's no continuity. Maybe there's one spot we'll get it. They're right on top of each other, but then as soon as you branch away from that, we get nothing. What about the terminal that's kind of clean here? Intermittent. We get some continuity, but not what we want. Let's try the other one. There's one in the middle here. Yeah, nothing. So as we can see, that corrosion ate away at that metal so bad, there's no continuity here, which is not good, of course. That's why we're not getting any power. Now I can actually stick this in this last lead over here, which is clean, and no matter where I touch that, you can see we're getting a beep. And the other one over here is obviously, that's not the case. Now I did read online, they said you can actually try hitting this with a little bit of flux through some, you know, like rosin solder here, rosin core solder, which is what I have in the background here. So I think I might fire up my Heiko here and give that a shot and see if that helps, because maybe plating it with some new metal on there will help. I'm being very doubtful though, because that's pretty shot. That would make a lot of sense to why this isn't getting any juice, because there's no connection between the terminals. So let me go ahead, I'll turn that on and we'll see what we can find. Hopefully we get something there. All right, I went ahead and hit all four terminals up with a little bit of solder. And can you guess what happened? Well, did you? I'll tell you what happened, because you probably guessed it already. The clean terminal took solder really well. As you can see, it's all shiny, silvery. The other terminals didn't do jack squat. They didn't take any solder, as one could expect, because they are that corroded. Now, what did happen though is the combination of maybe the heat and the rosin actually did eat some of the corrosion off a little bit better. And in fact, what I did was I went in here with a screwdriver, just a flat blade of a screwdriver, and just scraped at this, and that's why it has those little dig marks in it. But I scraped at it, and you can see it's actually shiny. In fact, I took a piece of this sandpaper, which is just really fine sandpaper, on like a plastic backing. This is like model stuff for making models with, you know, Testors brand. Anyway, I cut a little thin strip of it, and I just went in here and just sanded a couple of those terminals just to see how it would come out. And as you can see, it's definitely a lot better. That will probably take the solder. And the only reason why I'm actually soldering this is just I'm just tinning it. I'm just putting a layer on just to eat that oxidative layer off in hopes to have better connectivity. So that treatment I will continue with the other ones now that I see what's going on. I didn't clean this side up yet, so hopefully the camera can show you. You can't even see the terminal over here. That's how black it is, where the other ones are a little shinier. And it's the progression of already tinned versus the ones I started shaving down versus one I didn't touch at all. So that's definitely a big improvement. I'd like you to be able to see that. Yeah, there you go. This is the one I didn't touch yet at all. So I'm going to go ahead and continue on my course, and hopefully we can get these things looking a lot better. So far, so good. Well, unfortunately, our situation hasn't improved any, of course. They got cleaner than they were, but they're still not taking the solder, so it's a very good indication that there's too much corrosion on there still. Because if I can't get solder to wet to it, it's a pretty good indication. Unfortunately, most of the solder that I had heated up here and attempted to put on here kind of just splashed about in my nice anti-static mat, and this time I got a nice little nick in it, but that's alright, that happens. Not a big deal, it's only a rubber mat. But I'm a little bit more concerned with the fact that I just can't get this damn corrosion off these things. But I knew I would have that problem going into this whole thing. It was kind of I don't want to say I was defeated before I went into it, but I had didn't have high hopes that this was going to work. But I figured I'd give it a chance anyway, right? Because why not? I mean, this isn't something I really planned on using a lot of anyway, but you know, I'd rather would have the digital one working than the analog one. I mean, I know people like their analog meters better than their digital ones, but I grew up in a digital age, so of course, you know, I want to see the nice pretty numbers light up instead of a little knob. Speaking of this, I will still do a test run on this one to make sure it still works the way we want it to. And I haven't given up on this one yet. What I have decided to do is replace the terminals. Now, what that entails is drilling out these rivet holes. There's 3 rivets at the bottom, 2 at the top, and then I'll have to make new terminals. And it's a very thin piece of metal. They used brass here. I'm not sure if I'm going to be able to find brass locally. This is something I just want to be able to do cheaply. So perhaps my local Lowe's here has some kind of sheet metal panels or something like that, or maybe I have some loose metal lying around here from some pieces that I've scrapped. But either way, I'm going to have to trace out the pattern that's in here, these actual terminals here. Like I said, this one, and the one at the bottom over here are exactly alike because they're just passing current from one to another. The ones on the end here are more unique because that's the start of the chain and the end of the chain, if you will. So I'm going to go ahead and just design those up and replace the other ones as needed. But it's just going to be basically me just taking these out, lining them up on a piece of metal. I'll have to flatten them out, tracing them, cutting the metal, and then cutting them out of the metal. And then obviously I have to put the bend in it to make it fit in here. And that's really the only way I could think of revitalizing this particular meter. Will this happen right away? Probably not. I have a lot of other projects on my hands that I want to try to get into. This was the tip of the iceberg as far as meters were concerned. I have a whole slew of other ones we can play around with still. And you know, I don't want to get defeated on it yet though. So this is definitely something that's going to be put back into the case, but not put away forever. It's definitely something I want to revisit one more time to see if I can get it to go. And if that doesn't work, then that's the end of it. I'm not going to put any more effort into this one, because I already put half the day into it already, just trying to get this cleaned up. Not that it's a big deal. I got these for free, and you know, I guess there is the sentimental value to it. Do I have a place to keep all these things right now? Well, no, not really. You know, I don't have a lot of room where I am. But what I eventually would like to do is maybe in this particular studio, or I call it a studio because obviously I'm recording a video in it, but perhaps in this setting or another setting, eventually I'll have this stuff set up as part of a background, so you have all this vintage gear lying around, which should be pretty cool. But anyway, that's enough on this meter. I'm going to go ahead and just pull out the other one here, get the test leads out, and we'll play around with that one a little bit. Well, looks like I spoke too soon. Just on the whim, I put the batteries in and put the cover on. And it didn't do anything when I clipped it, but when I pushed the button on the side, you can see that they do light up. Which is kind of cool. So that means it's working to an extent. I'm not sure what the fluctuation in numbers here is. I should really read the manual just to see what I'm doing. I did try putting this around a wire just now, and of course it didn't really do much. But that goes to that whole thing about using these things. So let me go pull out the rest of the accessories so we can have a proper look at this. I quickly ran through the manual for this device just to see how it operated, and I'm glad I did. It pointed out some things I didn't really pay attention to when I first looked at it. First of all, this only works on AC, not DC, so that should be noted. It'd be nice if it worked on both, but I digress. This actually is a very easy unit to use. Unfortunately, I can't really test too much out with it right now, and I'll show you why. When you use this as an ammeter, you have to clamp this around one of the power leads. Now, if you know AC, it has line, it has neutral, and it has ground. This has to be connected around the line connection. If you take this and clamped it around a wire that had all three, you're just going to get a 0 reading on it. And unfortunately, I don't have anything in front of me right now that I can separate the two. But what I'm trying to say is, here's a power cord. You can see there's 2 wires on this. If I just took this meter and clamped it like this across these wires, it's not going to tell me anything. I need to actually separate it out. You can see at the end over here, there's the 2 connectors. I need to put this around one of those 2 connectors for this to work. And obviously it has to be a complete circuit. So just putting it on your lamp cord or anything like that's not going to work. Where this will work is inside of your electrical panel, where you have all the line wires and neutral wires separated. You can just go ahead and slip this in and it will tell you the amperage. Voltage though, I can test. And again, it's only AC voltage, not DC. And anything on here is up to 1,000 volts. 1,000 volts, 1,000 amps, or 1,000 ohms. That's the limit. The analog models, the model 1250, that goes up to 1,250. This is the model 1000, it goes up to 1,000. That's pretty self-explanatory. So obviously, you know, when it comes to resistance, you're not going to use it like a resistor checker per se, because it's only going to go up to 1,000 ohms. So if you have a, you know, 4.7 kilo ohm resistor, you're not going to be able to test it with this. But that's okay, because this isn't used just for necessarily testing the resistance of resistors. You're going to use this in situations like testing motors, like, you know, terminal to ground to see how much resistance is there, you know, different things like that. It has its own unique uses. Also on the back, I'll mention, there's a couple terminals. Not sure how much this will show up on camera. Try to angle it so you can see the text. This one's marked as volts, this one's marked as EXT for extension, and this one's marked ohms. You don't want to connect the terminal to the ohms here and check voltage, because you'll fry the meter. They specifically mention that in the book. The volts is where you're going to use to test voltage. That's pretty self-explanatory. And ohms is where you'll use to measure resistance. The extension jack over here. This is actually for a tachometer, which of course I don't have with the kit here. And then there's the jaw connection up the front. Now, the way this works is there's a fixed blade up here, which goes in, and that's your fixed probe, they call it. So you can hold this one hand and probed. Then the other one plugs in the back. So for testing voltage, we have to slip this into the voltage pin. And then we have our 2 points. So I should be able to stick this into an outlet, which I have one right here on my desk. And this should tell me we have 120 volts coming out of the wall. So I'm gonna go ahead and pitch up here. And my outlet is built into the bottom of my lamp. Oh yeah, and I'll also point out on the side over here, there's a gold button, which the gold is kind of wearing off a little bit, and there's a black button. The black button is the operate button, so when you push it in, you can see it lights up, and then when you let go, you get nothing. That's how you test this. So you would hold this down, clamp it over, or probe with the probe tips here, and it will give you your reading. And when you let go, it stops. Now what you have to do is use this little switch here. So if you push this down, you can push the switch forward and it locks the button downward. As soon as you move the switch back, this should pop out. Now it is hanging up against the inside of the case a little bit, so it is sticking, but it will release the numbers. As long as that button's being held, this number will continually change. And you can actually see the display kind of refreshes for a second here. You can see it right there. That little refresh is this thing constantly checking the readings. When you hit the peak hold button, it will stay whatever the highest peak is. So this is useful where you want to see what the starting load is on something, like a motor or anything like that. One use would be I can find the circuit that's in my room here, clamp this around the line feeding this room, hit it on peak, and then turn the breaker on, and all the machines, all the computers in here that are going to come on will obviously power up on their own, and this is going to give me that peak amperage of everything starting up. And then I can go ahead and turn around and see where the high number was, even though it says 4.4 now, but it might only be 3.2 at the time of the actual reading, but 4.4 was the peak. So you can use that to see where the peak is, whereas the other one, it's going to fluctuate up and down. And again, they both have that lock feature, so if you want to have the peak lock, you just push this and slide the switch down and peak lock stays on. So it's kind of neat. It's a little mechanical switch that does that. Actually, on the inside behind this, if you can hear it on my mic, it's got a physical micro switch. There's no like tactile dome or anything like that. It's a real switch. So they're built pretty well. So let's go ahead and daringly try this. It's either going to blow up horrifically in my hands, or it's going to give us 120 volts. So let's see what we got if I plug this in here. Yep, it's reading 100 and it's going up and down. Oh, it's overloading. Yeah, they said you'll get zeros. You'll see a bunch of 8s or 0s on here if it overloads. So let's try that again. Yeah, it's overloading for some reason. Not sure why. It's kind of weird. I am on volts, so I'm on the right jack here. Let's try it on peak. 120. 121. Now that will stay on that peak no matter what. I think you can see that on the camera, 121. It's pretty clear. They say that these red numbers can be visible in daylight, which is actually pretty nice. These older meters had that. The newer style meters, like my Fluke over here, had that nice standard LCD screen that you can't read. But yeah, you can see I've disconnected it from the device and it's still reading 121 because it is in that peak mode. If I go up the other mode here, we should have the zeros. I'll plug this in. It's 120, and you can see the display change every few seconds here. That's because it's constantly monitoring that number. So we know it works. I mean, the voltage reading works. Why wouldn't amperage work? I'll have to take this back out to the shed where I have some loose wires and I can actually, separate the neutral and the ground and line wires from one of those power cords feeding a piece of my equipment out there, and we can go ahead and play around with it and see how that works. But for now, I'm going to call this a working model. As you see, that went right back down again to 5. I'm not sure why it's displaying this default voltage of 5 here. In fact, as soon as you turn it on, you get zeros, and then it goes up to 2.7. Not sure why. It does that on both modes. I'll have to do a little bit more research on it. It didn't mention anything in the book about that happening. Oh yeah, and here's another fun thing. You can see when you plug the wire in, the outside plastic just slides right off that piece. You actually have to grab that and pull it out, or use a pair of pliers to pull it out. It's just from age, the plastic kind of went. Well, I'm going to go ahead and clean the digital one off the desk, and we're going to go ahead and give the analog one a shot. Well, the analog meter operates very similarly with some notable differences. First of all, there's only one terminal on the side here. This is where you're going to use to test voltage and ohms. And you also have the same screw terminal. This time it's dead in the middle. So it actually uses up space from the actual clamps, which is fine because you're not going to use the clamps and the probe at the same time. Other things to note on this, you can actually remove the screw here, and this part of the clamp can be removed for a larger clamp. So if you're actually putting this around a fatter cord, I believe there's other ones, or there's just different ends. I didn't have any pictures in the literature to show me what they are. The book did mention that this does take carbon zinc batteries. I don't have those. I only have alkaline, so it is what it is. We're just going to use those. The knob here changes the scale. Voltage and amperage is the same window here. So we can see right now it's from 0 to 5. If I flip it, it goes to scale at times 10. Or, yeah. Well, not times 10. It's just the next scale. 5, 10, 15, 20, 25. Then 25, 50, 75, 100, 125. And then 100, 200, 300, 400, 500. And then lastly, 250, 500, 750, 1000, 1250. So you can guess it can go either 1250 amps or 1250 volts. Now it says not to measure any amperage over 500 amps for continuous times, so that's something you're just going to kind of clamp on, test real quick, and take off. Imagine that much amperage, you know, clocking this thing up. It's going to probably make some stuff warm inside, or something's going to happen to it. And then if you go one more, it actually puts it into ohms range, which you can see the needle just pegs straight out over the end over here. I mentioned not to leave this in the ohms mode, because if you do, you'll drain your batteries. Other things to note too is there's the range extender, which when you push this, it kind of makes the needle go to the end. What you're actually doing is you're putting into like a double mode. So with that, you can actually get a more finite reading. It sweeps a little slower, so you can get a wider range of reading on it. And then the other one's the surge lock, so you can actually hold that down, clamp it onto your thing, or touch your probes, and when you, as long as you're holding it down, stop testing, it's going to hold that position at the peak point. So, of course, I'm going to go ahead and test this out on the outlet, see if we can get the 120 volts. But I have to make sure I get it into the right range. I can actually use the 100 to 500 range, and we want to see it, you know, obviously just above 100 and just below 200. I could put it into the 125 range, being that we were reading 120. Let's go ahead and give that a shot. Actually, let's just try that. So like I said, we're just going to screw that in and take the end of the probe here. The probe you plug in, this is actually fused. To get that, you just separate the halves, and there is the fuse inside, which of course isn't blown, but this is a specialty fuse. And the metal in here, the pin that comes all the way back to the end of this rod, that's all one piece of metal. Nice heavy, you know, heavy piece of metal. Both probes are exactly the same. Let's go ahead and try this out. We'll go ahead and pitch the camera back up here, and hopefully this one works just as well. Like I said, I'm more of a digital guy, as you can tell by my readouts here. But let's see. Again, just hope this doesn't fry in my hands. Oh, yep, right to 125. Let's put it on the next scale, 100 to 200. Yeah, it works pretty well. See, if I hold that surge down and disconnect it, you can see the needle holds right where it was, and when I let go, it goes back to 0. So yeah, it works a treat. We'll have to get to a place where we can test current on this. Like I said, unfortunately, it is an AC only meter. I do a lot more work with DC stuff, especially low voltage DC, than I do with AC. But like I said, this came from my dad's electrical collection from when he was an avid electrician. So of course he uses this a lot more than I possibly will, but I do want to have a clamp meter in my arsenal. And I'm probably going to stick with the digital one, just because I don't really have a pressing usage for either one of them, but I certainly don't need one that goes up to 1250 volts or amps, because most of the stuff I'm doing is the lower voltage stuff. Even if I'm working with 220 or 240 volt, I still won't need anything higher than that. I don't really touch any 480 stuff, and I don't really think I will be. I mean, can't say I'm not, but I don't have a reason to now. Of course, my favorite one, as always, is the classic Fluke 77, which does voltage and amperage, and both in DC and AC, and also does your standard ohms check. And this one I can go all the way, you know, from nothing to whatever the high range is on. I'm not really sure off the top of my head, but just for comparison, we'll throw this one in volts AC, 120.2, 0.1. Yeah. So they both work really well, and you know, just like every other tool, they all have their time and place to use them. Sometimes you need them more than others, but this will definitely be a good tool to add to my collection here. And well, I guess there's only one thing left to do, and that's to find a connection that we can tie this onto and check the amperage. I went out to the shed and I grabbed a lamp holder on a clamp and a 100-watt bulb, and we're gonna run this, test the amp meter here to see how well it works, if it does work for that function, which it should. Just did the math on this. If you do the 120 volt power out that we're getting here divided by the 100-watt bulb, we get 0.833 amps, or 833 milliamps, and that's what we should see on the meter. I mentioned originally we had to take the wire and separate it, and a regular lamp cord, any AC, you know, regular lamp cord is going to be a dual wire like this, and just putting the clamp around it isn't going to actually do anything for you, so you do need to separate these. There's a couple ways you could do it. I'm actually going to use a pair of nippy cutters here. Now this is a spare, like just a work lamp, so I'm not really worried about this kind of cord. I should actually do another video and show how to set up a box that's basically, maybe not even a box, an adapter that's going to have a plug-in on one end and an outlet end or a socket end on the other, and you can plug it in, and at some point the three wires will be separated. That's an easy thing to make. Maybe I'll do a video on that in the future. But I'm just going to go ahead and actually unplug this first, just in case. And I'm going to separate these two wires just by using my diagonal cutters here, just in between the two pieces. And just break through, and if you do it right, hopefully it won't affect the insulation on the wire. And as you can see, it didn't. It's fine. So I'm going to snap this back just a couple more snaps, just big enough to get the actual clamp inside there. And once you get to a certain distance, you can actually pull this a little bit, but I shouldn't really need to go more than that. I just need a little loop. So I'm going to plug that back in just to show it works. I have it aimed upward at the ceiling here, but I could turn this on and you can see it comes on. And we'll take out the first meter here. I have the analog one, and now I did mention this is in the milliamp range, so we do need to lower this down. We can go up to 5 amps, so we can, that's fine. We can't go any lower than that, so we should just see a little tiny bit of movement on this needle here once I stick this through. And let's see. And see, we did get some movement there. It went up to just about one amp. It's a little off based on the math, but I'll actually use a regular meter here and we'll see. Let's check out the other meter. This one, as you can recall, is our digital. So I'm going to put that around. Let's see how this works. Do I need to push any buttons on this? I'm assuming I do. It's not like the analog one, it just turns on. Right, so let's push down the read button. I'm saying 3.5, that can't be 3.5 amps. There's no way. I'm wondering if the calibration is off on this or if it indeed can be calibrated. Because it does 0 when you start it, but then it goes to either 2.6 or sometimes it goes to 4. So it's kind of weird. I should do a little more research on this particular one, just to see if it does indeed have some kind of a calibration mode or something you could put it into. I doubt it, because there really isn't any on the other buttons. And there wasn't any information in the book about it. So it was accurate on voltage, it's just not accurate on amperage, and I'm not sure why. It's kind of weird. But the important thing is, and the focus of this video is, it does power up. I was able to get the contacts in fair working order. Yeah, you can see it's a little bit above that 1 mark on the amps on this, but it is working. See if I'll show you that hold feature. If I hold this and take it off, you can see the needle stays right where it is, and then when you let it go, it releases. So that is a neat feature to have on there. But you know, time and place for these, as always. Sometimes you'll need them in one situation, sometimes in another. What I should do is actually cut that wire, and we could see what the actual amperage is on it. Yeah, it's not a bad idea. Let me do that. Alright, what I did here was cut the wire on the hot side. And on these polarized plugs, one blade is larger than the other blade. The larger blade is the neutral, the shorter blade is the hot. So we cut the hot line, and you can see here, there's the cut. The wire in the middle is the neutral, that's still intact. And to test current with the standard multimeter, you have to break the line, and we're actually continuing it. So it's coming from here through the red lead into the 10 amp line on my multimeter under the ohm, I'm sorry, not the ohms, under the amperage setting. The voltage in ohms is on the other pin. You don't ever want to plug current through like that. That's a whole subject for another time. But yeah, you always want to make sure when you're using one of these multimeters, you have your leads plugged into the correct terminals, or else you'll have a catastrophic failure for sure. Some of the newer ones actually are nice. You can't turn this knob unless they are actually in the right ones, either through a physical gate or an electronic monitoring system. But with the older ones, you do have to be careful. And also, you may or may not be able to see it in the camera. This says it's a 10 amp fused, whereas the other one's a 300 milliamp. I know my load here is more because I did the math, so I went with the 10 amp line, and that's always important to make sure you do that. If when in doubt, go with the higher rating anyway. So obviously I have it plugged into the right thing. I have my circuit connected. So like I said, it's going from the red through to the meter, back out the meter via the black or the common, back out, and that connects the circuit to the lamp and back through. And obviously, you know, AC and DC similar with connectivity. Just polarity is the only difference. So this is alternating, it's coming in and out, where with DC it's one, and then the other it's unidirectional as opposed to, you know, bi-directional, I guess you could say, like AC is. But anyway, I'm getting off topic. As you can see, once I turn this on, the meter goes dead on 0.83 milliamps, which is 830. You know, you're missing a digit here because it only has so many digits to display, but it is, like I said, 830 milliamps. It should be 833. I can't display the digit. You get the idea. So we definitely know that this circuit works. I should even be able to take this and just take one of these wires and put it around it, and it still goes up to that, just past 1 amp. I'm going to say this isn't really that accurate right now. It does need to be calibrated. There's a little knob up here that you can use a screwdriver, and I think I could set this back to 0. I think it's the way to do that, because it should be at 0 right now and it's not reading anything. So I will have to make that adjustment. On the digital one, I don't really see any way right away to test or calibrate it. So I should do a little more research. There, like I said, nothing in either one of these two books mentions anything about any kind of calibration other than you can change where the needle lies on this one. So that's an obvious one. This one's not so obvious. That should be giving me the 0.83 that we see up there, and it's giving me this 0.35, which is odd. And it's also giving me 2.7 without that. So I definitely think this is out of calibration, or maybe it's just not, you know, getting the right voltage because those batteries aren't right. It's not making the right connection between them, and possibly not getting the right voltage, and that's skewing the numbers. I would imagine it wouldn't light up if it didn't have the correct voltage going to it, but you know, it may only need so much voltage for that to operate, and then beyond that it needs the proper voltage for the unit to be accurate. I'm not sure. I can imagine that would be the case. Throwing off the voltage would throw off the measurement number, but without really knowing for sure, I can't say. But with that, that's really all I have to say about this particular video. I've been wanting to clean the terminals on those and get them into working condition again. As you remember from the video where I introduced some of this vintage equipment, I mentioned that I have a lot of it, and I did remember doing a walkthrough of most of it. Just brief if that. So I do have to go through the rest of the stuff I have. There's a whole shelf just above my desk here that has numerous different pieces on there from all different years. And like I said, I'll have to, you know, give it the same treatment. Some of them have corrosion, not as bad as these do. This is definitely the worst out of all of them by far, but you know, not definitely as bad as these, but there is still some. So I should you know, have some of those videos coming up in the future. And I also will have, possibly the next video will be working on the phonograph that's been sitting in my living room for the last week and a few days now. So I'll definitely have to do something with that soon. But anyway, thanks for watching, and as always, see you next video. If you have any questions or comments, please leave them below in the comments section. I always appreciate that. If you're not subscribed already, please subscribe. That helps me grow the channel. And thanks for watching.